Hello everyone, welcome to my channel. In this video, I'll discuss about what is a matrix and also around 9 very important types of matrices. Before I begin, I would like to start with two very good quotes which are very important. You need to understand and follow these quotes. The first quote is given by a great philosopher, Confucius. In this quote, I'll stress upon the last line, I do and I understand. So, while learning, don't just listen or see, do it to understand things well. Okay, so let's move on to the next second quote, which is by a great mathematician, Paul Holmos. Okay, the only way to learn mathematics is to do mathematics. The idea is very clear. If you have to learn mathematics, the only way is to do it. The only way is to work on it. Okay. So let's begin with the topic. So in this topic, I'll talk about first of all what is definition of matrix. An ordered set of m into n elements arranged in a rectangular array of m rows and n columns and enclosed by a pair of brackets. Brackets can be used square brackets or the parenthesis. Is called a matrix of order m by n. Here is your general m by n matrix which you can see on your screen. I have used two color combination over here. Green color numbers which you see represent row number, and the red color I have used to represent column number. Okay, this can also be written in short like this: a square bracket, inside that I'll write a general element aij, and that is again order of this matrix is m by n. Here I represent row index and j represent column index. So I will vary from 1 to m because there are m rows, and j will vary from 1 to n since there are n columns. Okay, so here is that my matrix, m cross n general matrix, m by n general matrix. So first of all, the thing which you see in green is nothing but the represent row. You can see the first thing is 1, 1, 1, 1 is nothing but the first row. This is your first row. This is your second row. This is your third row, and like that if we go, we will get m rows because the order of the matrix is m by n. Here m is number of rows and this n is number of columns. Okay, so you all can see this first index varies from 1 to m because there are m rows, and the second index varies from 1 to n. You can see the first column is here. All elements are having second index 1. Here is your second column. All elements here are having second index 2, and here the third column, and like that we have total n columns. Nth is the last column. There are n number of columns. Okay, let's talk about this short notation. Here this I represent row index, and this J represent column index. Since there are m rows, this I will take value either 1 or 2 or 3 up to m. And since there are n columns, this J will take value 1, 2, 3 up to n. Any one value can be taken. So for example, if I say, A 2 3, so this is nothing but the element which is present in second row and third column. If I say A 4 1, so this is nothing but element present in fourth row and first column. Let's take another example. Okay, so here I have a matrix of order 3 by 4. Okay, here I have a matrix of order 3 by 4. So suppose I pick, let's say, A31. So A31 is what? Third row, first column. So here is your first row, second row, third row. Here is your first column. Here is your second column. Here is your third column. Here is your fourth column. So I'm talking about third row, first column. So here is your third row, first column element A31. Suppose I'm talking about, let's say, A23. So 2 is the row number and 3 is the column number. So second row, third column. Here is your second row and here is your third column. So here is your element A23. I hope the notation is clear. So let's move further. So I'll talk about next some more blank matrices, some more matrices. Okay. So you all can see there is a matrix. What you need to observe here, you have two rows into this and there are two columns. So that's why order of this matrix becomes 2 by 2. There are two rows, so that's why the first number is 2. There are two columns, so that's why the second number is 2. The order of the matrix becomes 2 by 2. We can put any numbers into this. Let's say I am putting, let's say, 1 0 5 3. So we have an example of a 2 by 2 matrix. We can see a few more examples. Okay, so what you need to observe, as I said, number of rows and number of columns to get the order. So if you observe, there are two rows, so that's why 2 by, there are three columns, 3. So the order becomes 2 by 3. And whenever we talk about order 2 by 3, 2 by 2, 2 into 2 is nothing but 4. So there are 4 elements here. 2 into 3 is 6. So you can see there are 6 elements, there are 6 places to fill in this matrix. Okay, let's see one more. Okay, so what's the order? Number of rows, there are 3 rows. Number of columns, there are 4 columns. So order becomes 3 by 4. Okay, I hope you are clear with the what are the rows, what are the columns, what is order of the matrix. So let's proceed with the next. So you all can see I have one general matrix, and order of this general matrix is there are 3 rows and there are 4 columns. It's 3 by 4 matrix, general matrix of order 3 by 4, and there are total 12 elements you all can see. Okay, and with the different indexes. Okay, for example, if I pick, let's say, second row third element, second row third element, here is your second row third element, A23. Suppose I pick third row fourth column element, so here is your third row fourth column element, A34. Let's bring one particular example. Okay, so I have this one example, and we will talk about, first of all, what is the order of the matrix, what are the number of rows, what are the number of columns, and after that different elements present in this. So first of all, what are the how many rows are there? So there are, basically, you can see there are 3 rows and how many columns are there? So if you see, there are 4 columns, and order of the matrix is number of rows into number of columns. So order of the matrix becomes 3 by 4. So order of this matrix is 3 by 4. Okay. Then next we will talk about the elements. Okay. So let's say I'll say what is A14. So A14 means I'm talking about first row fourth column. So first row fourth column, you can see in the first row and in the fourth column. Here is your first row and here is your fourth column. So here is that element. Okay. So A14 is 0. Suppose I say A22. So that means second row, second column. Here is your second row and here is your second column. Here is your that element. So A22 is 7. Suppose I say A31. So it means third row, first column. So here is your third row and here is your first column. Here is your that element. So A31 is 8. I hope the things are clear. So I'll proceed next. Next, let's move on to types of matrices. These are the 9 very important types which we are going to discuss in this session. The first is row matrix, also known as row vector many a times. Second is column matrix, also known as column vectors. Third is square matrix. Fourth is identity or unit matrix. Fifth is null or zero matrix. Sixth is diagonal matrix. Seventh is scalar matrix. Eighth is upper triangular, and ninth is lower triangular matrix. These are the 9 types which you are going to see in this session. We are going to discuss this in this session. Here is your first type, row matrix or a row vector. Okay. A matrix having only one row and n number of columns is called a row matrix or a row vector. The order of a row matrix is 1 by n. Okay. If you read the definition carefully, it's talking about a matrix which is having only one row and there can be n number of columns. So that's why the order becomes 1 by n. That's what is written in the second statement. I have given 2 examples over here. The first example is a row vector or a row matrix with 2 columns. The second example is a row vector with 3 columns. Okay. So basically row matrix is what? Any matrix which is having a single row, only one row has to be there. There can't be 2 rows, 3 rows. There can't be 2 rows, 3 rows. But there can be n number of columns. Number of columns is not fixed. You can have any number of columns. You can have 1 column, you can have 2 columns, you can have 3 columns, you can have 4 columns, you can have 5 columns, you can have n number of columns. Let's take one more example. So I'm talking about a row matrix and also known as row vector. So basically order of a row vector is 1 by n. We have seen example of 1 by 2 and 1 by 3. Let's talk about now example of order 1 by 4. A row vector with 4 columns. Okay. So here is your blank example of a row matrix of order 1 by 4. Okay. To write a particular example, you can fill this 4 blank spaces. So suppose I fill, let's say 1, 0, -1, 4. Okay. So you got one example of a row vector with 4 columns. Okay. Let's go to the next. The next is column matrix, or also known as column vector. A matrix having only one column and n number of rows is called a column vector or a column matrix. So basically column vector or nothing but the column matrix is what? Which is having a single column. You can't have multiple columns here. You can't have 2 columns, 3 columns. You can't have. You should have only one column, but multiple rows are fine. Okay. So you should have only one column and you can have n number of rows. So as you see in the definition, there is one column and n rows. So number of rows becomes n and number of columns becomes 1. The order of such matrix becomes n by 1. Here are the 2 examples. First example is a column vector with 2 rows, and second example is the column vector or the column matrix with 3 rows. We can have similarly a column matrix with 4 rows. What is order of a column matrix? Order of column matrix is n by 1. There will be one column and there will be n number of rows, and right now we are talking about a column vector or the column matrix with 4 rows. So we are talking about 4 by 1 matrix. So here is that example. You all can see we have a column matrix. Why a column matrix? Because if you see the structure, that is having a single column and that is having multiple rows. There are 4 rows. So this matrix is having order 4 by 1. To get a particular example, we can fill this blank spaces. You can fill any number 0, -3, 2, 1. So we got one example of a column matrix with 4 rows. I hope the two types are very clear, row matrix and the column matrix. Let's move to the next type, square matrix. Okay, square matrix is what? A matrix having same number of rows and columns is called a square matrix. Same number of rows and same number of columns. Number of rows is equal to the number of columns. So suppose I say number of rows equals to 2. So to get a square matrix, you should have 2 columns in that, because equal number of rows and columns. So you can have 2 rows with 2 columns, you can have 3 rows with 3 columns, you can have 4 rows with 4 columns. So such matrix will have order n by n. You can see in the next statement I have written. The order of a square matrix is n by n. We also call it as square matrix of order n. So instead of calling square matrix of order n by n, we also call it as square matrix of order n. Single number will tell you what is the number of rows and number of columns, because both are equal. Okay, I have given 2 examples over here. First example is a square matrix of order 2. Second example is of matrix of order, square matrix of order 3. Okay, we can have square matrix of order 4 also. Let's see that. Okay, so now we are interested in getting example of a square matrix of order 4. Order 4 means that will be a 4 by 4 matrix. So here is your 4 by 4 blank matrix, 4 by 4 square matrix. Okay, to get a particular example, you just have to fill the 16 blank spaces. Okay, I hope that's very easy. So I'll skip this. I'll go to the next. So one more thing, that's a square matrix. So whenever we talk about square matrix, there are 2 terminologies come into the picture: diagonal entries and non-diagonal entries. The thing which you see here are known as diagonal entries, and the remaining are non-diagonal entries. This is non-diagonal entry. This is non-diagonal entry. Okay, let's understand by a particular example. I have taken one example over here. That's an example of 3 by 3 square matrix. And now we are going to discuss its diagonal entries and non-diagonal entries. This is your diagonal entry, and this is your non-diagonal entry. So basically diagonal entries are 3, 3, root 2 and minus 1. And the remaining are nothing but the non-diagonal entries. Let us see an example of a 3 by 3 matrix and we will discuss diagonal and non-diagonal entries in that. So let us first of all have a general matrix of order 3 by 3. So here is your general matrix of order 3 by 3. That's a square matrix of order 3, which we call. So we have to discuss here what are the diagonal and non-diagonal elements. So the things which are present here are nothing but the diagonal elements and the remaining are nothing but the non-diagonal elements. One thing you can observe over here, for diagonal entries, the row index and the column index are same, and for non-diagonal entries, row index and column indexes are different. So many a times we write diagonal entries as AII, where I will take value from 1, 2, 3 and up to n if we are talking about square matrix of order n. Here we are talking about square matrix of order 3. So your I will take value 1, 2 and 3. So that's why diagonal entries will become A11, A22 and A33. So the thing which is present diagonally in this matrix are nothing but the diagonal elements and remaining are non-diagonal elements. Non-diagonal elements we write it as Aij, where I is not equals to j. The non-diagonal elements are written like this: Aij, I not equals to j, and diagonal entries are written like this: Aii, where I will take value from 1 to n. Okay, let's take one particular example. So I'll take a square matrix of order 3. So here we have an example of a square matrix of order 3. Okay, and we can talk about diagonal and non-diagonal entries in this matrix. So these are nothing but the diagonal entries and the remaining are nothing but the non-diagonal entries. These are nothing but the non-diagonal entries. Okay, so diagonal entries are nothing but A11, that is 5, A22, that is 2, and A33, that is 7. And rest are nothing but the non-diagonal entries. I hope the idea is clear about diagonal entries and the non-diagonal entries. So let's proceed with the next type of a matrix. Okay, the next type is identity matrix, or also known as unit matrix. What is that? A square matrix in which diagonal elements are 1 and non-diagonal elements are 0 is called a identity matrix or unit matrix. So first of all, you have to focus on identity matrix is a square matrix. Then second thing you have to focus on, in that square matrix diagonal elements has to be 1. And third thing you have to focus on, non-diagonal elements has to be 0. This identity matrix has a special notation which is given in the next statement, IN. IN denotes identity matrix of order n. Example is given below. I have given example of I2 and I3 0. Let's talk about identity matrix of order 4. So here I have a blank matrix of order 4 by 4 and I have to give an example of identity matrix of order 4 which is denoted by I4. Okay, what we have to do for that? we have to put diagonally 1. Diagonal elements are 1 and non-diagonal elements are 0. So all other elements you have to put 0. So here you get I4, nothing but the identity matrix of order 4. Let's move to the next type. The next type is null matrix or a zero matrix. A matrix with all elements 0 is called a null matrix or a zero matrix. The null matrix is denoted by 0 m by n. So that is basically a null matrix of order m by n. Null matrix can be a non-square matrix, but identity matrix always a square matrix. You can see in the definition of identity matrix there is a word square in the beginning itself. A square matrix with diagonal entries 1 and non-diagonal entries 0. If you see the definition of null matrix, there is no word square over here. So null matrix can be a non-square matrix. So here I have two examples of two null matrices. The first one is null matrix of order 2 by 2 and second is null matrix of order 2 by 3. Null matrix is what? A matrix which is having all entries 0. Let's move to the next. The next type is diagonal matrix. What is a diagonal matrix? A square matrix in which all non-diagonal elements are 0 is called a diagonal matrix. In this type, first of all, you should have a square matrix. The next thing is all non-diagonal elements are 0. It's talking about only non-diagonal elements. That has to be 0. What about the diagonal elements then? Can have anything on the diagonal. I have given two examples over here. The first example is a diagonal matrix of order 2 and second example is a diagonal matrix of order 3. You can see in the first example on the diagonal you have 2 and 6 and rest of the places it's 0, that is non-diagonal element 0. In the second example I have diagonal entries minus 3, 7 and 0 and rest of the places are 0, that is non-diagonal element 0. So to construct an example of a diagonal matrix, you just have to put non-diagonal element 0 and on the diagonal you can put anything, either a 0 element or you can have a non-zero element. Okay, there is one more notation which is used, which I have mentioned in this example, DIAG 2 6. So there are two elements, that means I'm talking about a diagonal matrix of order 2 with the diagonal entries 2 and 6. And the second example I have written DIAG minus 370. That means that's a diagonal matrix of order 3 with diagonal entries minus 370. I'll write one more example. So suppose I'm talking about DIAG 2401. Okay. So 2401, it means what? I'm talking about diagonal matrix of order 4 which is having diagonal entries 2401. So I have a 4 by 4 matrix, blank matrix over here. So I have to put what? I have to put 2401 to the diagonal. 2401. And what about non-diagonal? Non-diagonal you have to put as 0. So here is that example of a 4 by 4 diagonal matrix. Let's move to the next type. The next type is a scalar matrix. What is a scalar matrix? A square matrix in which all non-diagonal elements are 0 and diagonal elements are same. Okay. So scalar matrix is a square matrix first of all. The second thing is non-diagonal elements has to be 0, and third thing, all diagonal elements has to be same. If you compare with the diagonal matrix, in diagonal matrix you can have different numbers on the diagonals and non-diagonal entries has to be 0. In this one, non-diagonal entries has to be 0, but diagonal entries has to be same. You can't have different elements, different numbers on the diagonal. Diagonal should consist of same number. Okay. It is denoted by k into in. This is special notation used for scalar matrix k into in, where k is any scalar which is present on basically diagonal, and in is your identity matrix of order n. Okay. And how we get this notation? Because your scalar matrix is nothing but a scalar multiplication of an identity matrix. What is a scalar multiplication? I'll tell you in the coming up session. Okay. So I'll not talk much about what is a scalar multiplication. You need to just understand that's a scalar multiple of an identity matrix. So that's why we denote it by k into in. The examples are given below. The first example is a scalar matrix of order 2, which is also can be written as 2 into I2. And second example is a scalar matrix of order 3, which can also be written as 7 into I3. And definition is what? Non-diagonal entries has to be 0. You all can see an example. Non-diagonal entries are 0. Along with that, diagonal entries has to be same. You can see diagonal entries are same. In the first one, diagonal entries are 2, 2. And the second example, diagonal entries are 7, 7. Okay. Let's proceed to the next type. The next type is upper triangular matrix. What is the upper triangular matrix? A square matrix in which all elements below diagonal are 0 is called an upper triangular matrix. I have given two examples of upper triangular matrix. The first example is example of 2 by 2 upper triangular matrix, and the second is example of 3 by 3 upper triangular matrix. In both the example, you can observe elements below the diagonal are 0. In the first one, there is only one element below the diagonal, that is 0. And there are three elements below the diagonal in the second example, and they are 0. What about the rest of the places? The rest of the places are free. You can put anything on the rest of the places. Let's see one more example. I'm going to construct basically an upper triangular matrix of order 4. According to the definition, upper triangular matrix is what? A matrix in which elements below diagonal are 0. So this is your diagonal, and elements below the diagonal are nothing but this. These are nothing but the elements below diagonal. So these elements has to be 0. So I am going to put 0 here. 0, 0, 0, 0, 0 and 0. What about the rest of the places? You can fill anything on rest of the places. So suppose I fill 1, 2, -1, 5, 3, 0, 2, 0, 0, 1. Okay. So we can have anything on rest of the places, either a 0 or a non-zero number. But what is important? You should have 0 below the diagonal. The next type is lower triangular matrix. This is very much similar to the upper triangular matrix. Just in place of, in the upper triangular matrix, what we do? We put 0 below diagonal. In this one, you'll have to put 0 above diagonal. Okay. Definition. A square matrix in which all elements above diagonal are 0 is called an lower triangular matrix. Here are the two examples. The first example is a lower triangular matrix of order 2. Second example is a lower triangular matrix of order 3. In the first example, you can observe there is one element above diagonal, that is 0, and there are three elements above diagonal in the second example, and they are 0. What about the rest of the places? Rest of the places, it's free. You can put any number, either a 0 or non-zero, doesn't matter. Okay. I hope all these 9 types are clear. So what I suggest to do this exercise which you see on the screen. You can pause your video and you can write down this and you can solve further. So exercises you have to solve. And what about the solution? Solution I'll discuss in the next video. These are the 10 problems which you are going to solve. Okay. And we will discuss solution of this exercise in the next video. So thanks for watching. And don't forget to like the video if you like the video, and comment, share and subscribe to my channel to get notification. Thanks for watching.